Hi, Assalamualaikum. So I'm from Group 7. So today I'll be presenting about our topic, which is in the question. We are from Group 7, and today I'll be presenting about our topic. So the question asks for use Laplace transform to obtain the yt in the following system differential equation. So there is given two equation here, and then given that the x equals to 0, y equals to 0, and dy dt equals to 1 when t is equals to 0. So here, the first step, you have to take out the first equation here, right here. So here is the first equation, right? So you have to use the Laplace transform to transform everything in the Laplace form. So here you get the first equation. You have already Laplace the first equation. So same goes to the second equation. Here is the second equation from the given equation. So you have to use the Laplace transform also to get this Laplace transform equation. So there is two equation. So substitute the second equation that you have Laplace just now into the first equation that you just Laplace just now. So you will get this equation, you subject the y, and then you will get this equation. In this equation, you have to use the partial fraction to get the value of a, b, c, and d. So how to get the value of a, b, c, d? As usual, you have to cross the denominator, and then you will get this equation. So in this equation, you have to expand everything, so you will get this long equation right here. So in this long equation, you have to use the comparison method, and then compare the S3, S2, and S. So after you compare the value of S3, S2, and S1, you will get the below equation here. So the three equation right here. So you have to substitute the second equation and into the three equation, yada yada yada, until you get the value of a, b, c, and d. So after you get the value a, b, and c, and d, you have to substitute back the value of a, b, c, and d into the partial fraction equation. So here is the equation after you substitute it back. So the question asks to use the Laplace transform, right, into the to obtain the yt. So the yt is inverse of the Laplace transform. So you have to inverse the Laplace transform back. You have to use the inverse Laplace to inverse back to get the value of the inverse. So inverse one by one. So after you inverse one by one, inverse this one, and also this one, and also this one, and you will get the final answer. So here is the Laplace, the inverse Laplace of what you have get just now. So after that, you have to inverse Laplace everything and that will be your final answer. That's it. Thank you.